Now let us talk about the next type of graphical representation of data, that is histogram, right? So first we'll be dealing with histogram of uniform width, right? So let us see, we have a question here which was similar to the continuous class interval question. We are given the weights in kg of different students, right? So we have class intervals as 30.5 to 35.5, 35.5 to 40.5, right? And the number of students who are having weights in this category, they are given to us, or the frequency is given to us, right? So we need to note that histogram can only be made when the class intervals, they are continuous, right? As you can see here, the upper class limit and the lower class limit, they are equal to each other. So I can conclude that the class intervals, they are continuous, right? So it can only be made when class intervals, or let's say CI stands for class intervals, they are continuous, right? So let us start with this question. We need to represent this data on the graph, right? So first of all, what I need to do is I need to make a vertical axis and an horizontal axis, right? I'm going to call the vertical axis as y axis, and I'll be calling the horizontal axis as x axis, and where both the axes, they are meeting, I'll be calling that point as O, right? So first of all, we need to make some points on the vertical as well as the horizontal axis, right? Let me rub these points. Right? As I can see that in the question, we'll be dealing with the weights and the number of students. So let's say I'll be representing the weights on the x axis and the number of students on the y axis. I'll be representing the weights on the x axis and the number of students on the y axis. Right? You can interchange it as well, but it will be easier to draw inferences or conclusion when the graph is made in this form, right? The weights on x axis and the number of students on the y axis, right? So as you can see that the weights, they are starting from 30.5 and they are going up till 50.5, right? So I can see that I can't start from origin here. If I start from origin, then it would take so many divisions to reach till 30.5, right? And as I can see that the interval, it is of 5 units, right? So I can't take more than 5 units as my unit on the x axis, right? So what I need to do is I need to just get to this interval, that is 30.5 and 35.5. For that, I'll be using this sign, which means that you can directly, let me write it at the bottom, this is called as kink, right? When the observation, it doesn't start from 0 but starts from a bigger number, right? You directly make this symbol, right? It's like a mountain, uphill and downhill, right? You make this symbol, and this means that you directly jump to this value. So I'll be starting with 30.5 here. Let me write 30.5 and 35.5, right? So on x axis, 1 unit is equal to 5 kgs, right? 35.5 minus 30.5, that is equal to 5 kgs. So 1 unit is equal to 5 kgs. So similarly, this will be 40.5, this will be 45.5, and this will be 50.5, right? I have plotted all the points that are required on the x axis, right, with the help of a symbol that is called kink, right? Similarly, I need to represent the number of students on the y axis. As I can see that the lowest number is 3 and the highest one is 14. So how many divisions do I have? 1, 2, 3, 4, 5, 6, 7, 8. So the unit that I am going to take is 1 unit is equal to 2 students, right? 1 unit is equal to 2 students. So let's say this is 2, 4, 6, 8, 10, 12 and 14, right? So I have represented up till, let's say, 16 on the y axis. Y axis, let me write here number of students, and the x axis weights, which are in kgs, right? Now let us start with the first observation that we have. 30.5 to 35.5, we have 9 students falling in this category. So we'll be making a rectangle, right? 9 students. So where does 9 lie? It lies somewhere in between 10 and 8. So let's say this point corresponds to 9, right? So 9, I'll be making a rectangle. The procedure to make a histogram, it is similar to that of a bar graph, right? The only difference you'll be seeing is that here the rectangles, they will be continuous to each other, as the class intervals, they were continuous. So the next class interval is 35.5 to 40.5, right? So we have 5 students in that class interval. So 5 lies somewhere here. So that will be, right, this corresponds to the class interval 35.5 to 40.5. The next one, 14 students lie in this class interval. So 14 is here, right? So let me just draw the rectangle. This represents 40.5 to 45.5. Now the next one is 3 students fall in this category. So 3 students, 3 is somewhere here, right? 3 students, they fall in this category, right? So our histogram looks somewhat like this, right? And as you can observe from this histogram, that the width of the histogram, right, it is constant. The width of the histogram is constant, right? So this was the first category, that is histograms of constant or uniform width, right? As you can see that we can draw inferences from this histogram. First of all, I can say, let me rub this. The difference between a bar graph and a histogram is that histogram is made for continuous class intervals, and all the rectangles that are corresponding to the class intervals, they are continuous on the x-axis, right? The next point that I can make is the area of the rectangle. Area of this rectangle, it is, or I can say, frequency. The frequency that I am talking about is nothing but the number of students, right? The frequency is proportional to the area of rectangle. Frequency is proportional to area of rectangle, right? Now I can see that because the width, it is constant for each and every rectangle, I can write this area as length into breadth. Area of a rectangle is equal to length into breadth, right? And because the breadth, it is constant for each and every rectangle, I can conclude that frequency will only and only depend on the length of the rectangle, right, or the height of the rectangle. This is the length of the rectangle, right? So the frequency will depend on the length of the rectangle. So the rectangle having the maximum length or the maximum height will have the maximum frequency. Maximum length corresponds to maximum frequency, right? And minimum length corresponds to minimum frequency, right? So I can see from this histogram that here this one 40.5 to 45.5, maximum number of students, they fall in this category, right? It is very easy for me to compare the data right here. This class interval contains maximum number of students, right? And this class interval, it contains the minimum number of students. This corresponds to minimum, right? And this corresponds to maximum, right? So histogram with uniform width, it makes it easy for you to compare the data, right? The only change is that the rectangles, they will be touching each other or will be continuous on the x-axis.